Hi, this is Gunasekaran, Assistant Professor of Mechanical Engineering at SNS Institution. Now we are seeing about introduction to helical spring. Already we have seen helical spring and introduction to spring. This part is fully seeing about helical spring. Okay. Here introduction to helical spring. Common mechanical parts that are used in many different applications are helical spring. Okay, usually constructed from the coiled wire. Their purpose is to store and release mechanical energy. Okay. Types of helical spring. First, we are seeing compression spring. Seeing the image, say one part of is extension spring, then another one is a compression spring. Okay, seeing difference between this spring. Okay, here compression spring are helical spring designed to resist compressive force when applied axially. They are typically made from a round wire and are widely used in various applications. Okay, where they provide the linear resistance to apply forces. Okay. Structural function: compression spring consists of cylindrical coil with gaps between each turn, allowing them to compress when a force is applied along their axis. Okay. This compression store potential energy when is released when the force is removed, retaining the spring is original length. Here mostly applications for automotive, industrial machinery and consumer goods. Consumer goods mean toys, electronics devices and furnitures. Industrial machinery is conveyor system, compressor and stamping presses. Okay. Automotive means suspension system, engine valves and brake mechanism. Design consideration means mainly focus on the wire diameter, coil diameter and pitch influence spring rate. And load capacity. Okay, we are seeing second one is the extension spring. It means a helical spring designed to resist tensile force when pulled apart. Okay, when pulled apart means it is a it means a small size of length in spring. It is a where pulled when pulled apart. Okay, tensile force when pulled apart. They are made from round wire or futures loops or hooks at the ends to facilitate attachment. Extension spring store mechanical energy by stretching under load and release. It is when force is removed, retaining the original shape. Here mainly seeing structural functions. The spring constant of tightly one coil that extension when pulled. Exerting a force opposite the applied load, the force exerted is proportional to extension distance as per Hooke's law, making them ideal for applications recurring control tension. Here applications is for extension spring, garage store and tools and equipment. Okay, garage doors mean providing counterbalancing force. Okay, tools and equipment, tensioning mechanism and retractable cords. Okay, here focus on the design considerations means factors such as the wire dia, already seeing a coil diameter and length influence spring rate and maximum extension capacity. Properly designed and installed. Okay. Extension spring offer reliable force applications and retraction in industrial and commercial and consumer applications. Okay. This here torsion spring. Spring that exert rotational force or torque when twisted about the axis. Okay. They store mechanical energy by resisting angular displacement, retaining the original original positions when the twisting force is released. Okay. Here structure, the spring consists of tightly wound coils usually with legs or ends that are attached to other components. When torque is applied to ends, okay. Here also applications in carriage doors, clocks and watch, and automotive. Okay. Finally, here seeing direct shear stresses. This refers to the stress experienced by the material of the spring due to the applied load or force that causes shear deformation within the cross section of the spring or coil. See, coil support and spring compression or extension means the shear stress can be significant at high load. Okay. Here also, impact of the performance, excessive shear can lead material fatigue, reducing spring life and even failure if the stress exceeds the material shear length. Okay. Okay, thank you.